Welcome back to the Cloud Essentials course. Today we're going to talk about common terms and really the definitions when we're talking about cloud computing. Now, cloud computing is clearly a buzzword that's been around in the industry for a little while now and is being used in the market in many different types of software and network services, not of all which really fit into a proper technical definition of the word cloud. So, before we examine the use, impact, and the security issues of working in the cloud, it's also very necessary to define what cloud computing really is. Cloud computing, at the end of the day, is just a kind of internet based computing that provides shared processing, resources, and data to the computers and other devices on demand. It's a model for enabling ubiquitous, on demand access to a shared pool of configurable computing resources, such as networks, servers, storage, and even applications and other services. These can use to be rapidly provisioned and released with minimal management effort. Cloud computing and even storage solutions provide users and enterprises with various capabilities to store and process their data in third party data centers. It relies on sharing of resources to achieve coherence and the economy of scale, which is similar to the utilities such as the power grid, for instance, or even your water bill. You pay for what you use, and that's it. So, in cloud computing, we also need to understand what a data center is. So, a data center can be a facility that's used to house computer systems and its associated components, such as the telecommunications and the storage systems. It generally includes redundant or backup power supplies, as well as redundant data communication connections, environmental controls such as HVAC, and various security devices. A lot of large data centers actually can use up to the same amount of electricity that some small towns use. Now, almost anything can be hosted within a cloud. It could be databases and even applications up to complete virtual infrastructures encompassing data storage, networking, and all the components of a server environment. The cloud can also host virtualized user desktop environments that are available from any network client device, whether or not the client has sufficient local resources to host a virtualized desktop environment and its various applications. Internet based of off site managed hosting services have been around for quite a while. These have been available through specialty providers such as Rackspace since 1997, and even provided value additions by local internet service providers. However, cloud computing goes beyond simple hosting of websites or databases that you might have used in the past with Rackspace and even other ISPs. For example, if you're a Google Gmail user, you've actually been using a base of the cloud for quite some time, because cloud can also be email, for instance, through Google Gmail and other Google apps, which really started showing off the power of the cloud back around 2006 or so. Cloud computing has several characteristics that we'll talk about, such as email accounts, data storage, servers, which is the virtual servers, and websites. In fact, as we move throughout this course, I think it's going to be really important for you to understand that we really wouldn't have the cloud today if it wasn't for virtualization. So we'll also take a few moments and talk about just what virtualization is and why it's so important in the cloud industry. Now, the capacity and resources available to cloud computing services can be increased or decreased, with costs that are adjusted according to the actual consumptions of those services. This is going to allow an organization to spin up new offerings or services with only minimal cost for the resources used, then to meet the spikes or even a cycle that use patterns for increased capacity, which allow us at the end of the day to pay for only what the level of resources that we need. Now, traditional data centers, on the other hand, must always plan for future growth. For example, a sudden success for a web-based offering can rapidly overrun available server and network capacity unless the data center managers purchase a significant spare resource beforehand. Cloud computing, on the other hand, draws resources from a pool as they're needed. This is based on the level of service consumption. This is similar to the way that power companies supply power or individual organizations, billing each according to its individual actual use. Now, for example, in the cloud, a new application might experience a sudden increase If, for instance, a blog article got a lot of hits, then the CPU, the server memory, and even the data storage and network bandwidth will have to suddenly keep up with this increase of demand. With traditional data centers, this would be limited by the hardware constraints, while cloud computing alternatives can simply add CPUs or expand available database file storage up to predefined limits when needed, and then shrink it back down once the storm of this particular onload of access demand goes back down. This is actually going to help you manage what's called on-demand costs. Cloud computing is also managed by the provider. Cloud computing services are managed by the cloud provider themselves. For instance, once applications and services have been moved to the external cloud computing, an organization is no longer going to need to worry about local data center issues regarding power, space, cooling, and the developers need only know whether their applications will be running on one cloud service or another. For example, could it be Amazon Elastic Compute or Microsoft Azure? Now, without having to consider whether the services or application resources, where they're going to be located, knowledge of the individual hardware characteristics and the capacity measures is really no longer important to the organization, while tech refresh and update becomes a background matter for the actual cloud provider and not the end user themselves. It's also nice with clouds to be managed through self-service, on-demand services. Now, after limits for resource availability are configured within the cloud provider system, available resource capacity can be automatically expanded or managed by the client with minimal effort. Bringing up a test server no longer requires access to the physical system, loading of the software, configuring the network by hand, and instead the customer needs only access to their cloud provider and request a new resource allocation using this self-service user interface. Now, as long as the organization's contractual limits on the resources allow this addition, it's managed automatically without further technical assistance at all. These services are also network accessible. Cloud services are available via a network device, such as facilitating rapid access by mobile customers and remote office locations. This provides an anywhere, anytime service model that would not have been possible with traditional data centers, where service downtime and local area outages and power and even networking can impact your uptime. Now, because the cloud computing vendors can be located anywhere in the world, they can host organizational services from areas outside of geographical turmoil or wherever there's been a natural disaster. Now, for example, before a hurricane, a cloud service provider could transfer operations from Florida up to Washington transparently without the customer even knowing it. Clouds are sustainable. Because cloud providers can provision resources as needed, it's also possible to reduce power and cooling requirements during off-peak times, gaining economies of scale well beyond those available to single-tenant hardware-based data services, which must stay on waiting for later use. In other words, in traditional data centers, our server farms are going to be running 24 hours a day, 7 days a week, and you're going to pay for the electricity and the compute for those services regardless if you have any load on them or not. So within cloud computing, we have flexible resource assignment. They're going to be managed by the provider, managed through a self-service on demand, and it's all network accessible, and the cloud is very sustainable. Before we end this particular lesson, let's also talk about what the cloud computing characteristics that would be stated by the National Institute of Standards and Technology. These definitions by NIST are intended to serve by a means for broad comparisons of cloud services and deployment strategies, and to provide a baseline for discussion from what is cloud computing to how best to use that cloud computing. Again, as we mentioned before, on-demand self-service. A consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. It's broad network access. Capabilities are available over the network and accessed through standard mechanisms that promote the use of heterogeneous thin or thick client platforms, such as mobile phones, tablets, laptops, workstations, etc. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using what's known as a multi-tenant model, with different physical and virtual resources that are dynamically assigned and reassigned according to the consumer demand. In other words, the provider is offering the same hardware platform and virtual platform across the cloud that each and every tenant and or user can then use those as it's needed. With the cloud, we get this sense of location independence and that the customer generally has no control or even really any knowledge over the exact location at a higher level of abstraction, such as the country, the state, or even what data center that their resources are going to be within. Examples of resources including storage, processing, memory, and even network bandwidth. A big characteristic of the cloud is rapid elasticity. When we say that the cloud is rapid elasticity, this means that we can be rapidly providing and provisioning, in some cases automatically. We can even scale rapidly outward and inward. So again, if we have that blog post and things are getting really popular on our site, then our resources are going to need to be thrown at that particular blog site. So we may need to actually provision more IOPS on our storage. We may need to provision a better database, etc. We can throw more resources to that on demand. As that demand goes up, and then as that demand goes back down, then so will the provisioned resources that were thrown at that particular blog site will also be able to cool down and go back down to less resources as that demand goes down. Cloud resources are measured. This means that cloud systems automatically control and optimize resource use by leveraging a metering capability at some level of abstraction that's appropriate to the type of service. Again, whether that's storage, processing the bandwidth, and how many active user accounts are being used. Resource usage can be monitored, controlled, and even reported, providing transparency for the provider as well as the consumer using those resources. So that's it for this lesson. Let's go ahead and finish it up and move right into the next one now.